What's up, chem nerds? This is the periodic table practice exam taken by yours truly, Garbal Poi Camino. I'll give you guys a few guesses as to what that name is referencing. But anyway, these are 30 questions from last year's exam here for you guys to practice with to get yourself familiarized with the language of the questions you should expect to see on Wednesday's exam. And we are going to start with number 1. In the ground state, an atom of each of the elements in group 2 has a different what? Alright, so when talking about elements in the same group, they should have the same number of valence electrons. Especially when you're in group 2, they all have 2 valence electrons. So that we can immediately cross off choice 2. That's what happens when I forget to switch things on and off. Alright. Now, down to these other 3 choices. Let's check oxidation state. So oxidation state is the same as the charge you see in the top right corner of each element box. That kind of ties in with the number of valence electrons, what kind of ion they become. So that's also tied in with choice 3. So choice 1 is also off the table. Now we're down to 2 and 4. So first ionization energy you could actually look up on table S, and you'll see that each of them are different. So each element itself has its own different first ionization energy. Now let's see why number 4 is not an option. Number of electrons in the first shell. So that's the inner ring of electrons, the inner shell, the one closest to the nucleus. And every element in the periodic table could only hold 2 electrons max in that first shell. So if you look down group 2, they all have more than 2 electrons. They go past the first shell. And so that one's also off the table, because all of those group 2 elements should have 2 electrons in that first shell if you check its electron configuration. So it's choice 2 for number 1. Number 2, which 2 elements have the most similar chemical properties? So most similar chemical properties, we should think same group, that's the vertical column down the periodic table. So we could already knock off some of these guys. So group choice 2, hydrogen and helium are not in the same group. Let's see. Phosphorus and sulfur also not in the same group. Some of these I'm kind of going offhand from memory, but I kind of need the reference table. So also, hint for you guys, use your reference table, periodic table, your best friend in this particular exam. So let me pause for a moment to get that out. Alright, so now we have our reference table and we're looking at each of these choices to see if they fall in the same group. So we're down to 1 and 4. So beryllium and magnesium, so Be and Mg, they both happen to be right here in the same group, so that's our answer. But let's also see for potassium and strontium. Potassium is K, strontium is Sr, and that's over here. So these 2 are not in the same group. These 2 are, because same vertical column. So our answer here is choice 1. Let's do a different color for the next question. Alright, number 3. Which general trends in atomic radius and electronegativity are observed as the elements in period 3 are considered in order of increasing atomic number? So we're going across a period from left to right. So we're going from here to the end, Na to Ar. So going across a period, we start off with our largest atomic radius, and it goes down till it reaches argon with the smallest atomic radius in that period. So it goes down. Atomic radius decreases going across the period. So we could cross off choice 2 and choice 3, because atomic radius should decrease. Now we're also going to see with electronegativity. So here's the trick I usually go by, and what I usually tell my own kids to do, is to remember which elements have the highest and use them as a reference point. So fluorine happens to have the highest electronegativity of 4.0. It's the highest on the scale. And so if you go further away from fluorine, you decrease. But if you go closer to fluorine, you increase. So going from left to right, you're getting closer to fluorine, so you're getting closer and higher to 4.0. So going this way, electronegativity increases. Okay, so atomic radius goes up, the opposite. Atomic radius goes down, electronegativity goes up, and that's choice 1. They don't go up and down the same. way. Alright, number 4, we're talking about ionic radius. Which ion has the smallest radius? So this ionic radius topic is not going to be on the test, but it's still good to review ions in general, and atomic radius basically. Which ion has the smallest radius? So we're looking for the smallest one. So notice how they're all the same type of ion. So the number of electrons here is not going to really matter in terms of how many gained or lost. So they're all here, 2 minus, so that's group 16. O, S, Se, and Te. Oxygen, sulfur, selenium, tellurium. If you're looking for the one with the smallest and going, remember the trends for the group, the smallest ones are up here, biggest ones are down here because you keep adding on electron shells as you go down the group. So the one with the least number of shells is going to be here, oxygen at the top, because it starts off small here and gets bigger as you go down. Think of them as adding more layers, electron shell layers. So it's choice 1. So the ionic charge doesn't really matter here, we're just looking at them in terms of down the group. Still following the trend. Number 5, which property can be defined as the ability of a substance to be hammered into thin sheets? So thinking about hammering and something you can mold, that's malleability. Okay, number 6. An atom of a non-metal generally becomes an ion. So non-metals becoming ions. So if we look at non-metals, we should know they're on this side of the periodic table towards the right. So non-metals usually become ions. They become negative ions. That's important. They become negative ions by getting more electrons. So to become negative, you got to get more electrons. And that's choice 2 here. You don't change protons, you can only change electrons. And to change charge, you gotta change your electrons. Okay. Moving to the other side of this page, 7 through 13. Which list of elements contains a metal, a metalloid, and a non-metal? So I'm going to quickly pull up my periodic table in a quick moment. Okay, so periodic table, you're always going to have this on every test, so better get used to it. So metals are all on the left side, metalloids are by the bolded staircase, and the non-metals over here towards the right of the staircase, just not touching it. Okay, so we're looking for one that especially has them. It didn't specify in order, but just so we at least have one of each. Okay, so we gotta look at each of them one by one. So choice 1, Ag is a metal. That's the metal in the list. Choice 2 does not have any metals. So we can cross off choice 2 because germanium and astatine are both, oh that's not astatine, that's arsenic. Oops. As is arsenic. And neon, neon is a non-metal. Germanium and arsenic are metalloids. So that doesn't have a metal at all. Okay, number 3, choice 3, there's potassium and copper and bromine. We have 2 metals there, so that's not valid. Potassium and copper are the 2 metals there. And choice 4, we have sulfur, chlorine, and argon. Those are all non-metals. So just to verify that choice 1 is correct, we have silver, the metal, silicon, the metalloid, and iodine, the non-metal. There we go. That's why it's the answer. Number 8. Which Lewis electron dot diagram represents an atom in the ground state for a group 13 element? So key thing about group 13, they have 3 valence electrons. So we gotta look for the dot diagram that shows 3 dots for 3 valence electrons, and that's choice 3. Okay. Number 9, which list of elements is arranged in order of increasing electronegativity? That means we go from low to high. As the list proceeds, we get bigger in electronegativity. And right off the bat, I could cross off choice 2 because I know fluorine is the highest. You can't start with the highest if you're going to go higher. Okay. So let's see. Another trend is that if you're up here, further down you go, the lower the electronegativity. So you want to go from low to high. So we want to probably start near the bottom and go our way up. Or we could start on the left and go to the right. So generally start in this corner and going all our way towards fluorine to get increasing in electronegativity. So we could look at choice 1. We got Be, Mg, and Ca. That's wrong because you're going down and further away from fluorine. So let's see, potassium, calcium, and scandium. Potassium, calcium, and scandium going here, this direction. We are going higher, so perhaps that's the choice, but let's just double check with choice 4. Lithium, sodium, and potassium. Going here, here, and here. We're going down again, just like with choice 1, but that's also wrong. So it's gotta be choice 3. Okay, number 10. Which compound forms a green aqueous solution? The keyword is green. We need to think colors and transition metals. Transition metals are right here in this section from groups 3 to 12. We're looking for elements that fall under there. So Rb is rubidium. That's group 1. Doesn't count. Choice 2 is calcium. Doesn't count because calcium is over here. Then we're left with nickel and zinc. Nickel and zinc are over here. And there's no other way to know, but there's probably some typo or mistake in this problem because there can't be 2 valid answers, but it happens to be nickel. But either way, if you, without any knowledge of the color green, just know that it had to be a transition metal. Choice 3 and 4 are both valid because they're both transition metals. Okay. Number 11. Which statement describes general trends in atomic radius and electronegativity as you go left to right? Didn't we just do this? Going across to period 2? Anyhow, we already did this in the previous question before that looked like number 3. And just know that electronegativity goes up as we go across and atomic radius goes down, so that's choice 3. Which element is least likely to undergo a chemical reaction? So this is keyword for something that is stable, doesn't want to react at all. So when we think stable, we should think noble gas, because they have 8 valence electrons. Everybody wants to be them, hence why they're noble. And choice 4 is correct, because neon is a noble gas, part of group 18. Number 13. At STP, which element is malleable and a good conductor of electricity? So we're thinking something that is a metal. And out of all these choices, choice 3 is correct, platinum. Number 14, which group 15 element exists as a diatomic molecule at STP? So when you see the word diatomic, you're going to think of that phrase. Depends on which teacher you have, but I tell my kids this phrase, Hankelbrief. So the letters or the symbols in this phrase tell you all the elements that are diatomic. Hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. Most of them are all in group 17, but there are a few others that are not in group 17 that are diatomic. So diatomic meaning 2 atoms together make up that element, or the molecule of that element. Alright, so group 15 N is diatomic. So, not diabetic, diatomic. Group 15 over here. So, based on Hankelbrief, the only one that fits is nitrogen. So, let's spread the word of Hankelbrief, because Mr. Ballant keeps trying to overtake the chemistry empire, and we are not going to let him win. Just saying. Just saying. Anyway, number 15. Which quantity identifies an element? Whatever Brinkelhoff nonsense he keeps spewing. It's Hankelbrief, my dude. Hankelbrief. Anyway, number 15. Which quantity identifies an element? Wow. Atomic structure review, guys. So what is the one thing that identifies an element? It's atomic number. Oops. It's like 10 something, 10:46 p.m. right now. I'm going delirious. I've been spending too much time at the pool. Alright, number 16. Which atom has the greatest attraction for the electrons in a chemical bond? So keyword is greatest attraction for electrons. We have to think electronegativity and which one has the greatest. So we're looking for the element with the highest electronegativity. So I like to use, once again, fluorine as our reference point here. Fluorine has the highest of 4.0, and if you're around fluorine, then you're likely to have a really high number. So looking at each of these, there's hydrogen, sulfur, oxygen, and silicon. So we could cross off these two because they're very not as close to fluorine as oxygen and sulfur are. So we need to double check with table S just to make sure we're not picking the wrong one. So we're going to pause and quickly pull out table S. Okay, so I'm not going to have table S pop up, but anyway, just know that you can find those values on table S right after this periodic table. And I found the values of oxygen to be 3.4, while sulfur is 2.6. So greatest attraction has to go to oxygen for 3.4. The second highest from what I've seen. Number 17. Which period 4 element has the most metallic properties? So period 4 means we're over here, and most metallic means we're over on the left side, the leftmost element here. But none of them, AS, BR, GE, and SC, are over on the left side, so we gotta look over here. So AS, GE, SC, and AS, and BR. Okay, so AS, GE, and BR are over here, but SC is all the way over here. Okay, so scandium is going to be the most metallic because it's the most on the left side. It's a transition metal, by the way, whereas the others seem to be metalloids and a non-metal. So choice 4 is the answer. Okay. Number 18, compared to a potassium atom, a potassium ion. Okay, so again, ionic radius. We're not going to be too concerned about that when it comes to the actual test, but let's see. Let's still answer this to review ions. Potassium atom here loses electrons to become a positive ion. So if we could think about drawing out K, I'm going to draw it over here. Oh god. It's got that many. It's got 2, 8, 8, 1. When it loses an electron to become an ion, it loses an extra electron shell. So it's not accurately drawn to scale, but we get the idea. So then it becomes 2, 8, 8. So it becomes smaller because it loses an electron to become that ion, that K plus ion. It's a smaller radius. Not because of protons. It's still the same number of protons, because otherwise you're not going to have potassium. It's got to be electrons. Okay, so number 19. What occurs when a magnesium atom becomes a magnesium ion? So a magnesium atom it starts out as neutral, becomes an ion. Magnesium is a metal, so it becomes positive ion. So it goes from a charge of 0 to positive 2. When you're positive, you lose electrons. And when you lose electrons, you become less full, become smaller. Kind of like what we did with number 18 for potassium. You get smaller when you lose electrons. So electrons are lost, and oxidation number increases or decreases. So when we're positive, we increase. So it's choice 3. Okay, number 20. Which element has atoms in the ground state with the greatest number of valence electrons? So we are looking for something that's further towards the right because they have more valence electrons. Okay, so we got tin, which is Sn. That's in group 14, so that's 4. Arsenic has 5. Sulfur has 6, and fluorine has 7. So based on that, we're going with fluorine. Choice 4, right there. I have to do that weird wide circle because otherwise I'd be tapping on other buttons by accident. Oopsies. Alright, then we're going to bust out 21 and 22 and 23 on the same page. So 21. Which list of symbols represents non-metals only? So we're looking at things that are completely on the right side here. And we could cross off choice 2 because we have metals in there. Choice 1 also has a metal. Aluminum's a metal, guys. Choice 3, carbon is a non-metal. Silicon's a metalloid, and so is GE, germanium. So that's not it. It's got to be choice 4. Phosphorus, sulfur, and chlorine are all non-metals. Okay, number 22. Talking about trends in first ionization energy and electronegativity values when we're going top to bottom of group 15. Okay, so thankfully it's easier because these two things go together. They go up and down together. So group 15, we're going from top here to the bottom. So both ionization energy and electronegativity are the highest in this corner. Fluorine has highest electronegativity, helium has highest ionization energy. So in this corner, we have the highest values. Going down, we decrease in those values, so they both go down together, going down the group. Okay, so it's choice 1. Let's go back to blue. If you guys didn't know, these are my favorite colors, blue, green, and purple. That's a fun fact about me. Number 23. What is the charge of the nucleus of a copper atom? So what is inside the nucleus? That's protons and neutrons, no electrons. So everything here should be positive. Let's also move this guy over. Periodic table's in the way. There we go. Copper is Cu, as you guys should know from that recent element quiz. Copper is Cu, not Co, that's cobalt. Copper here has an atomic number of 29, so it has 29 protons, which means its nucleus is plus 29. Okay, so number 24, we're comparing the radius of potassium ion to radius of potassium atom. So we just answered a multiple choice question relating to ion and atom. So ion, giving it's positive, it lost electrons. Ion is smaller than the atom. And that's all you need to answer that. Okay. Number 25, we have to identify the noble gas whose atoms have the same electron configuration as the potassium ion. So we need to upload that periodic table, and I'm going to bust it out in a moment. And it's right here. Okay. So we are comparing potassium. When it loses that electron, becomes the noble gas of period 3. So right here. Moves up 1 period all the way to the end. So its configuration is going to match that of argon. So you go from 288 to 288. Oh, sorry. Go from 2881 to 2888. That's argon. Okay. Number 26, 27, 28 are together based off this prompt. So we're talking about the Dobereiner. I don't even know how to say this guy's name. Still want my dude Mendeleev. Okay. Let's talk about triads. Okay, triads are 3 elements together. Okay. So number 26, explain in terms of electrons why the electrons in triad 2 have similar chemical properties. So we should think when you have similar chemical properties, you're in the same group, so same number of valence electrons. Another key thing with these free response questions, when they say in terms of something, you need to state it. Somewhere in your answer has to mention it. So we're going to say that they have same number of valence electrons. And so that takes care of that requirement. Same number of valence electrons. Okay. Number 27, identify the triad that contains a metalloid. So metalloids are here in this staircase. Boron, silicon, germanium, arsenic, antimony, tellurium, PO, and astatine up here. I don't remember what PO stands for, but that's the only one I don't know out of this group. Okay, has a metalloid. So it's definitely tellurium. Tellurium is a metalloid. Let's check the others. Nope. Nope. And nope. So it's only triad 1. Okay. State the trend in first ionization energy as the elements in triad 3 are considered in order of increasing atomic number. So triad 3, chlorine, bromine, and iodine, we're going increasing atomic number. So we're going from chlorine down to iodine. What is the trend in first ionization energy? So it's highest up here with helium. It goes down as you go down the group away from helium. So the trend is that it decreases. Alright, so this technician guy took some data from his experiments, and here's some data from it. Number 29, state evidence from the technician's data which indicates that sodium is more active than aluminum, so we need to actually state stuff from the reference, not the reference table, from this data table. So stating evidence means you just copy down what was given there. So we need to figure out why sodium is more active than aluminum. So based off the data table, it says it reacts vigorously. So reacts vigorously with cold water, whereas aluminum has no observable reaction. Number 30, identify the element that's classified as a metalloid. So I've seen while grading the reagents, actually, this particular reagents, the most common mistake was that people do not know the difference between aluminum and silicon in terms of metalloids. So silicon is absolutely one of the more common and obvious metalloids. Aluminum is hard to tell, and that's where a lot of kids made mistakes on, but it is silicon for a metalloid. Aluminum is more metal. It may lean a bit in the metalloid region just because it's right there, but it's all, for the most part, metal, given that this whole identification process is a spectrum. There's not going to be one perfect metal, non-metal, or metalloid. It's a spectrum of characteristics that it can lean one way or the other, and aluminum is most definitely more metal, and silicon is absolutely a metalloid here. Alright, and that is the end of this practice exam. Alright, so I hope you guys go through these 30 questions, familiarize yourself with the language, get yourselves prepared, because Wednesday's test is definitely going to be very reference table heavy. So get yourselves familiar with your new best friend there. Alright, have a good night, guys.